Hello and welcome to this new tutorial. Alright, so in the previous tutorial we took care of the first step to update the weight of the neural network of the discriminator, and now we're going to tackle the second step, updating the weights of the neural network of this time the generator. So it's going to be easier than the first big step. Break down the error between the real error and a fake error to compute the total error. This time there will only be one error, the loss error between the prediction of the discriminator whether or not the image generated by the generator should be accepted, yes or no, and the target, which will be equal to 1. Why will this be equal to 1? That's because this time we want the generator to have some weights that allow his brain to produce some images that look like real images, and therefore we want to push the prediction close to a target of 1. This time we're training the brain of the generator to be able to generate some images that look like real images. So that's another key point to understand. The target will be equal to 1, even if this time the image that will be the input of the discriminator will be the fake image of the generator. Alright, so let's do this. It's going to be faster than previously. We're going to start by initializing the gradient of the generator with respect to the weight to 0. And let's do that efficiently. We simply need to take that line of code again because that's the same thing we did for the gradient of the discriminator. So I am pasting it here and then replacing netD by, of course, netG. We want to initialize the weights of the gradient of the generator this time. Then, next step. Well, the next step would naturally be to get the input, but the thing is we already have the input. You know, the input is going to be this fake image, or should I say this mini batch of fake images that are going to be, again, the input of the discriminator. So we already have the input, we already have the fake images of the mini batch, and therefore we're directly going to get the target. And so this time, according to you, what is the target going to be? Is it going to be a mini batch of zeros or of ones? Well, as I explained in the beginning of the tutorial, this time we want to push the predictions to 1 because we want the discriminator to accept that the fake images are real images. So the target for all the input fake images of the mini batch should be all ones. And therefore, I'm taking this line of code, copying it, and pasting it right here to get my targets of ones. Great, my target is already wrapped into a torch variable. Perfect, I'm allowed to move on to the next step. So now what is the next step? Well, the next step is to get the output. The output of the discriminator when the input is our fake images. Therefore, I'm getting a new variable output, and I'm taking my neural network of the discriminator, so netD, and I'm feeding this neural network of the discriminator with the mini batch of fake input images. And so for each of these fake images, I'm going to get the discrimination, that is, I'm going to get the discriminating number between 0 and 1. If this number is close to 0, the image will be rejected, and if this number is close to 1, the image will be accepted. Now, something important. Remember that in the previous output we detached the gradient of fake. This time we're not going to do it. Why is that? Because we want to keep the gradient of fake. We want to keep the gradient of fake because we're going to update the weight of the neural network of the generator. And to update these weights, we will actually need the gradient of fake. So that's why it's important here not to detach it. Alright, next step. Now that we have the output and the target, well, we're ready to get the error of prediction. But this time, this error of prediction is going to be the error related to the generator because we will backpropagate this error back into the neural network of the generator, as opposed to before, where we backpropagated the total error back into the discriminator. So that's important now to understand that this error is related to the generator, and therefore I'm going to call it ERRG. ERRG, that I'm going to get from my criterion that is going to compute the loss error between the output and the target. The output, which is the output of the discriminator when the input is the fake image, and the target, which is the mini batch full of ones. Alright, so now that we have the error, we can backpropagate it in the neural network of the generator. So I'm taking this error ERRG, then dot, and then I'm applying the backward function, which, keep in mind, so far only compute the gradients, but then we are going to use the optimizer of the generator to make sure that this time it's going to be the weight of the generator that will be updated. Therefore, I'm exactly going to take the optimizer of the generator, optimizer G, to update the weights of the neural network of the generator. And here we go, the second step is done. So congratulations, now basically the difficult part of the training is done. Now it's time for fun. We're gonna print the losses inside the loop, so we're gonna stay in the loop. Then we're gonna save the real images and also, of course, the fake images. And then eventually, after the training, the fake images and the real image will appear in this results folder that will contain the final results. So let's do all this fun stuff in the last tutorial of this module. I'm super excited to show you the results. It's going to be something. It's going to be pure computer vision creation. So prepare yourself a good coffee or a good tea, sit comfortably in your chair, and get ready for the final results. Until then, enjoy computer vision.